Okay, now, on the last set of example problems we'll look at here, what we want to do is we want to factor each polynomial, if it's possible. If the polynomial can't be factored, we'll write the word primed. So I start with example 1 here. I have 5x squared minus 80. First thing we do, does anything go into both of them? Well, yes, 5 does, doesn't it? So I factor out the 5. So I'm going to say 5. I like the purple better. I'm going to go 5, factor the 5 out. So I get x squared. 80 divided by 5 is 16. I got a binomial left over now. Since I have a binomial, x squared is a perfect squared, 16 is a perfect squared, so that means I can factor that again. So the square root of x squared is x. The square root of 16 is 4, so I go x plus 4, x minus 4. Then I look at my binomial again. Can I factor this again? Well, x is not a perfect square, so I'm done. Can't break that down any further. So your answer is going to be 5 times x plus 4 times x minus 4. Let's take a look at example 2 together. So we look at this term. Does anything go into all three of them? Well, 9 is 3 times 3. 6 is 3 times 2, but 3 does not go into 35, does it? So that is not I don't have a common factor. 9x squared is a perfect squared, but 35 is not a perfect square, is it? So I can't use my perfect square rules. So I notice I have a leading coefficient, so then I'm going to use my British method. I'm going to take 9 times negative 35. So 9 times negative 35 is negative 315. And I want to find two numbers that multiply to negative 315, but are 6 apart. And so that means my bigger number has to be negative. So I'm going to do some guessing and checking here. So 1 and negative 35, I know doesn't work. 2 does not go into 315. I think 3 does, though. 3 divided by 315 is, what is that, 105. So 3 and negative 105. That adds a negative 102. So that's not. 4 does not go into 315, but 5 does. So we're going to say 5, I take 315 and I divide that by 5, I get negative 63. They are not 6 apart, are they? Okay, 6 does not go into 315, nor does 7, nor does 8. Let me see, does 9 go into 315? 5 plus 1 is 6, plus 3 is 9. So yes, 9 does. So let's take 315 divided by 9, and I get 35. They're 27 apart, aren't they? So that is not correct, but I'm getting closer. 10 does not go into 315, nor does 11, nor does 12, nor does 13, nor does 14. I should have checked. Did I skip 7? 7 and 45. Forgot about that one. But I know 7 goes into it, but 14 does not go into it. How about 15? So let's take 315 divided by 15, and I get negative 21. Look at that. Those two are 6 apart, aren't they? So I'm going to use 15 and negative 21 to factor. So I'm going to say 9x squared plus 15x minus 21x minus 35. I look at my first two terms, 9x, whoa, didn't have my pen there. 9x squared plus 15x. What goes into both of those? Well, 3x goes into both of those, doesn't it? So I have 3x, and then I'll have 3x plus 5. Look at my next two terms. I notice my leading coefficient is negative, so I'll factor out a negative. What goes into both 21x and 35? Well, that'll be 7, won't it? So negative 21x divided by negative 7 is a positive 3x. And negative 35 divided by negative 7 is a positive 5. Look at that. Our parentheses are the same. So we can factor the parentheses out. So we have 3x plus 5 and 3x minus 7. And that would have been a long one to guess and check to figure that out. I notice 3x plus 5. Now I got a binomial. 3x is not a perfect square, so I'm done. I can't factor that anymore. Let's take a look at example 3. First thing I look at example 3, notice, ooh, we've got bigger exponents this time, don't we? So that's going to change things around. First thing, though, always start. Does anything go into all three of them? Well, I notice for 8 and 18, 2 goes in all the lows, doesn't it? So we're going to factor out that 2. So I'm going to factor out the 2. So I'll say 9x to the 4th plus 12x squared plus 4. Now I look inside that parentheses. It's a trinomial. My first term was a perfect square. My last term was a perfect square. I wonder if I could factor that down. So I'm going to say 2. I'm going to guess. I'm going to say 3x plus 2, the quantity squared. The reason I said 3x plus 2, the square root of 9x to the 4th is 3x. The square root of 4 is 2. Now let's check to see if I get 12x squared. Oh, it's not 3x though, it's 3x squared. Because the square root of x to the 4th is x squared. Now, let's multiply. So if I take 3x times 2, 3x squared times 2, I get 6x squared, double that, I get 12x squared. Yes, that works out. Now, look inside your parentheses. Can you factor what's inside the parentheses? We've got a binomial. 3 is not a perfect square, so we're done. You can't factor that anymore. Let's do another one. Each one is a tad bit different. On this one, the first thing I notice, unlike the other ones, there's nothing that goes in all three of, or to both of these, is there? However, I notice this is a perfect square, and I know x to the 4th is a perfect square. So I'm going to take, I think that's a difference of squares, and so the square root of 625, well, that's 25. I'll say plus, and the square root of x to the 4th is x squared. And then I'll say 25 minus x squared. Now it gets interesting. I look inside my parentheses. 25 is a perfect square, and x squared is a perfect square. But the first one is a plus. You can't factor that. But we can factor 25 minus x squared, because that's 25 is a perfect square, and x squared is a perfect square. So I'm going to, the square root of 25 is 5. And I'll say the square root of x squared is x. And then 5 minus x. I'll just bring down that first parentheses, 25 plus x squared. Now, if I look at my parentheses that I just factored, can I factor those again? Because 5 is not a perfect square, so I can't factor that. So we have 3 terms that this polynomial factors to instead of 2 terms like we've had for most of them. And there's your answer.